So, my name is Yishay Carmiel. I'm always joking that you can hear that I have a very thick Israeli accent. Just a little bit background about myself. So I've been working in the speech space for more than 15 years now, founded multiple companies. Meaning is actually my fourth venture. I founded company, started working on deep learning since 2012, 2011, founded a company that is applying deep learning for speech recognition. And then this company got acquired. Started working on analyzing human conversations, and Meaning is actually, as I said, my fourth venture. And what we are doing in Meaning in very, very short terms, we are doing voice and accent conversion in real time. So basically, I'll just show you some kind of a very, very quick demo. It's going to be, don't worry, it's going to be just 1 minute of a demo, so you can see what we are doing. So actually, this is a real-time live demonstration of our technology over Zoom call.
Sure thing. So let me just share my screen. So one of the things that we've built a very powerful technology that enables us to transform any person's voice into a target voice avatar. So this is Daniel. Daniel is a person, he's an actual person. He was born and raised in the US. He's based in Baltimore. And without further ado, let me do.
And now, I'm not if you know, I'm still shy, but I'm not speaking with my take heavy Israeli accent. I'm speaking as downhill, hopefully where you can enjoy my American accent right now, and we can have a live conversation. Maybe I can give a little bit of explanation about the LLM technology. Riza said we have a very, very powerful novel that does in real time voice and accent conversion. And basically we train these neural network that it knows how to take any type of voice, regardless of the accent, in terms of even my and Israeli accent, and convert it into a target speaker. In this case, it's Daniel. Someone.
Amazing. And it's back to my voice.
Yeah. So unfortunately, you're going to hear my voice right now, Daniel, in the talk. So yeah, so you're going to suffer. Thank you so much. Okay, so I don't want to talk a little more about Meaning. I just want to give you a little bit brief about what's happening in speech and audio. So if you're thinking again, everyone is talking about Gen AI right now, and for the right reasons. So we see a paradigm shift that is going from analysis to synthesis. So if you're thinking about up until 18 months, something like that, all of the deep learning algorithms were taking data and starting to analyze that. And now we have everything that is generating new stuff. So you see a lot of things that are happening, of course, in LLMs, in computer vision, and I bet that everyone has been experimenting with that. And I want to talk a little bit what's happening in this speech. Okay, so first of all, voice is everywhere. And again, I'm biased because I've been in the voice space for more than 15 years, so I think that voice is everywhere. And usually when I'm talking about speech and audio, people are asking me a very natural question: what do you care about voice? Okay, LLMs are super cool, Midjourney is awesome, we can generate a lot of images, why do we care about voice? And so first of all, when we're talking about voice, it's not just voice. We can talk about audio, we can talk about music. And again, if you're thinking about it, us as humans, the most natural way for us to interact with each other is through voice. So we want to understand voice, and we want to speak to machines, and we also machines to speak to us. So if we're talking about the two main core technologies that we're thinking about voice, one of them is, of course, speech recognition, which everybody understands that we're trying to take some kind of a signal, that the signal will recognize our words or our spout of speech, and the other one is speech synthesis. And another thing that is happening right now, again, we are talking about user content generation. So if you're thinking about generating new content, so as I said, music and audio are just a key part of the things that we are doing, that when we are talking about audio and speech, these are the same algorithms because we are talking about one-dimensional signal. So think about videos. When I want to create a video, and audio is a core part of the video. I can generate new soundtracks, new sounds, new music. So when we are talking about user content generation, videos and audio as part of the video is something that is very crucial. I've been involved a little bit about games in terms of how we are dealing with audio for games, and gaming are a huge new use case for all the things that are happening. So think about that in gaming. You have the gaming side of it, or the production. But a lot of the things that are happening in gaming is that the audio production is a massive, massive amount of investment. So think about that we want to create, for example, we want to bring voice actors. If you're talking about like a multiplayer game, we need to bring 150 or even 200 voice actors into the audio. And a lot of the things that are happening right now in games, that it's not a one-time thing. You know, every time that I'm creating a new version, I need to create another game. So the question for the audio production guys, am I going to bring these voice actors every time that I need something? I don't know if my contract has ended with a voice actor. What do I do about it? So generating new content for games is something that is very, very emerging, and a lot of things that are happening in the what we call the speech synthesis and audio and music synthesis. And one of the things, and hopefully we'll have time, you can generate new types of music. And like when I'm working, I always need music. So one of the coolest things that you can do is you have what we call music LM, which you can literally inject the kind of music that you want to hear, and it's going to generate for you. So that's pretty amazing. So just before I go into my talk, I just want to give you a glimpse, because I assume that not all of you have a PhD in speech recognition, and not all of you have been done speech. So just for you to understand a very, very high level of how we're thinking about speech. First thing, speech recognition. Okay, it's very simple. I'm speaking to the machine needs to understand me. Okay, like it takes words or sentences and to understand me. Second thing is what we call speech profiling. Speech profiling is basically taking anything that is related to understanding speech. For example, who is the user? What's the age of the user? Its emotional state. Okay, this is what we call speech profiling. And usually the definition is everything that is related to speech, which is not speech recognition or speech synthesis. Speech synthesis, literally generative AI for speech. We are trying to generate new types of speech. So what do I want to cover today? So first of all, the most important thing, how we generate new types of speech. And I want to give you a little bit of a glimpse into this world and what is the latest and the greatest things. I don't want to be too technical about talking about neural network architectures. I just want to give you a very level high overview of what's going on and what's going on in these things. Second thing, which at least for me, it's something that is very cool, and this is called LLMs for speech. So one of the things that is happening right now is that if you're thinking about LLM, of course, the classical LLM can take text, words, generating output words. But one of the things that it's some kind of a new generation. So people in the speech community or in the audio community are generating new acoustic sounds. And there are so many cool and use cases. For example, I was talking about music generation. Music generation is based on LLM for audio. And the last thing that I think it's super important to talk about, because these things are happening right now, is what we call ethics and safety. Not sure how many have heard about what we call voice cloning. Okay, this is a tough audience. I'm going to explain to you about what is voice cloning and about audio fakes and what is happening over there. So yeah. So, okay, what is generative AI for speech? So if you're thinking about it, again, I tried to give you a very high-level overview. So when you're thinking about speech, we can think about the input and the output. So first of all, the classical thing is what we call you have an input of text, and you can generate speech. And this is what we call text-to-speech. One of the things that, that happened until 18 months ago, that it was a very classical system. I'm inputting some kind of a text, and the system just say that. The thing that is happening right now with LLMs is that I can say, for example, to the system, say, hello, my name is Yishay, in Barack Obama's voice when he's pretty sad, or when he woke up in the morning. So this is what he called prompt TTS, and it's a combination of LLM for text plus LLM for speech, and it's getting a lot of attention, probably, for the right reasons. The second thing is what we call speech-to-speech, and this is basically what you've seen in the demonstration. I'm taking one part of speech and convert it into another part of speech. Sometimes it's called voice conversion. There are a lot of underlying technologies. I would give you a glimpse about what's going on over there. The third thing is what we call text plus speech and its output from speech. For example, I can say to a system, here's the text, here's the voice that I want you to say, here's a reference of the user that I wanted to say that, please output that. So this is like a combination of text to speech plus voice conversion. Usually we call it style transfer. Text to music, you're going to see a demonstration. Again, like some kind of a open source demonstration. And of course, there is what we call speech and music plus speech. For example, one of the things, actually it's speech plus text, that I can put my voice, for example. I can say, and it's going to create me singing plus an audio track. So if you're thinking about it, the amount of things that we can do with that, just with LLMs and generative AI, it's pretty gigantic. So this is like as complicated as it's going to get. I'm not going to go into technical details, but if you're thinking about text-to-speech block diagram, in a very high-level terms, we have like three key parts. The first part is what we call NLU, okay? The second part is what we call that, we're trying to take these text, and I'm going to deep dive a little bit into that, and create something that is called a representation of the speech. It's called text-to-mail. Sometimes, like in recent years, there have been like more advanced things. Then the second and the last thing is what we call vocoder, takes this representation and literally generates speech out of that. The reason that most of the time these two are two different blocks, because up until like 12, 18 months ago, the quality of combining these things together was not good enough. If you can see it, at the bottom, there is what we call end-to-end speech systems, which we are trying to combine these things together. So what does it mean, the NLU part of a text-to-speech? So, okay, so this is, for example, like, so when I'm writing something, okay, so for example, my email is abc@gmail.com, okay? A text-to-speech, one part of the speech is, we call text normalization, because, this is not the classical input that the text-to-speech system needs to get, okay? So we need to do something that is called normalization. My email is abc@gmail.com. This is the classical input that the text-to-speech system needs to have. So we do have a neural network that does this transformation. And as I said, one of the things that is happening right now with prompt TTS, that we have another layer of neural network that knows how to add a layer of metadata to these text-to-speech systems, how to convert. For example, I want to say my name in Barack Obama's voice when he's happy. When in Barack Obama's voice when he's happy, some kind of a metadata layer that is injected into the text-to-speech. Just one example that I'm always using. Sometimes we need a little bit more sophisticated. We don't need we need to use neural networks to do that, because, for example, look at the number 1939. It can be 1939, it can be 1939. It really has a context. So I wouldn't say large language model, it's over-exaggerating. Some kind of a language model will solve the problem. So the second part is what I call we need to generate a speech. So we generated some kind of a metadata or some kind of a textual input, and now we need to take these texts, create some kind of what we call speech representation or some kind of a meta-layered representation of this speech and generate a speech out of it. Okay, so this is a neural network. Again, like I need to show some kind of an architecture of a neural network in my talk. So this is what I call almost the latest and the greatest speech architecture. It's called WITS. And if you're thinking about it, it's what we call, if you remember, I told you that we are trying to combine the text the representation plus the vocoder together. It's what we call an end-to-end speech. It has something that is called a duration predictor. What does it mean? Basically, for example, I can say, hello, my name is Yishay. I can say, hello, my name is Yishay. So basically, based on the emotional state, based on a lot of other metadata, we're trying to create, the duration of the phonemes and the duration of this information. And actually, a lot of these things, there are a lot of, very nitty-gritty tricks how to train this system in a very efficient way that the sound will be very, very natural. One of the things that it's very important to emphasize is what we call multi-speaker TTS. So one of the things that is happening in TTS that I'm collecting data of a single person, and the TTS generate this single person super, super, super well. The question right now is that if I want, for example, to adapt the voice into a specific user, this is what we call a multi-speaker TTS, that the TTS knows how to do that. But here's the thing, here's the catch. If you remember, I talked about audio effects and voice cloning. This is exactly the risk about these systems. Because, for example, if I'm getting a person recording and these multi-speaker TTS are all over the place, we can get, just download, I can create I can clone someone's voice. And it sounds very, very natural. So, okay, so what's the latest and the greatest of state-to-speech? So, avatar and dubbing. I'm not sure, for example, there was a very viral video on Twitter last week. It's of Hagen. Somebody was speaking, and it literally translate his voice into other languages. So dubbing is a solved problem. Spotify, for example, released 2 days ago something that all of their podcasters can translate their podcast into other languages. This is a solved problem. It's working. Editing, dubbing, lip syncing, everything is working. What is still under development, and when I'm saying under development, it's not for 5 or 10 years. It's going to be solved in the next 18 to 24 months. It's what we call conversational speech. As you see, it's very different when I'm giving a talk, speaking in a very fluent way, than rather reading from a script and making sure that the text-to-speech system or I can synthesize a very, very high expressive. This is super important to gaming, because again, like in gaming, like these things are pretty critical. Okay. It's not working. Oh, it's working. Okay. Let's talk a little bit about speech-to-speech. Okay, so speech-to-speech is basically one of the things that you saw in the demonstration. So what is the difference between speech-to-speech and text-to-speech? Speech-to-speech basically is trying to create one part of voice and convert it into another part of voice without going through the word space. So think about, for example, that if I want to take my voice in real time and do what I showed you, going into the word space, first of all, is going to create latency. Because I have pretty thick accent, speech recognition systems might not recognize me pretty well, so some of the words are going to be misrecognized. And one of the things that is happening, especially in speech, is that 80% of how we speak is not with the words, it's like with how I say all of these things. So if we were like, no, we are going to that, that's going to be a little bit tricky. So one of the things that is happening with speech-to-speech, and again, we are just taking the latest and the greatest things from both sides, for example, like encoder architecture from the speech recognition and decoder architecture from the text-to-speech, combine them together into some kind of a neural network. I thought that fingerprint network is going to be a cool name, but again, like it might be not, and do that at one thing. So that's basically. Let me just show you one example of a voice conversion. Okay, so let me just so if you think about voice conversion, we have the source speaker.
I've done nothing wrong, and that's the truth.
Okay, we have the target speaker.
He felt there was no case to answer.
So one of the things that we're doing in voice conversion, I want that the target speaker will say what the source speaker is saying.
I've done nothing wrong, and that's the truth.
Okay, so this is basically voice conversion. And if you're thinking about voice conversion, again, I can make, like with very, very short voice samples, I can make somebody sound really like the target speaker that I want to. So again, like talking about safety and ethics, that is why I'm saying that these things are happening right now, and we need to be very, very careful about these underlying technologies. So one of the things that if somebody is interested in understanding more, and there are a lot of open source, one of the latest things that has been released is what I call VoiceBox by Meta. What is VoiceBox? So basically, it's a multi-speaker TTS, very high-quality multi-speaker TTS, one of the best that I've heard. It's also does what we call style transfer. So basically, for example, I can inject, if you remember, I can put a text plus speech, and it's going to sound like the output target speaker that I'm going to do. It has a lot of very, very cool things of editing and noise removal. So we can enhance audio quality, removing noise. So all of these things, I think, that are underlining some kind of one gigantic neural network. And one of the things that is happening right now also, like, I bet that in a lot of other things, is consolidating all of these different tasks that were happening under variety of neural networks under one single neural network. So that is why it's very, very impressive work. And I encourage you to listen to some of the samples over there if you're interested in that. Okay, so the second thing that I want to talk about is what is called LLM for speech. What is LLM for speech? So if you're thinking about an LLM, it's some kind of a neural network that takes like 99.9% of the times text and generating another text out of it. So it's some kind of a transformer architecture. What does it mean? What can you do with speech? We can do, for example, with audio or with music. We can take these very small snippets of what we call acoustical units and ask the neural network to generate new types of acoustical units. Okay? The input can be text, the input can be speech, but think about it that I can say, for example, I want to listen to urban music in a sound of, in a 1960s style, and it's going to generate that if I have enough training data, and this is exactly what's happening, for example, in what we call music LLMs and audio LLMs, a lot of very, very cool things that are happening right now. So one of the things, one of the classical things that happen, it's called UBERT, based on BERT. I think that in the last 6 to 12 months, models are becoming much bigger, like the classical things, being trained on thousands and thousands of GPUs for thousands and thousands of hours. If somebody's interested, I can reference you to some of the open source. Some of these models are existing over there, and they are getting pretty good attention, and they are becoming very, very powerful. So again, I'm a speech guy, so this is like one of the slides that I'm most excited about. For you, probably it's not going to be that exciting, but I've been working back in the days in something that is called voice compression. So basically, voice compression, I'm trying to send my voice over a channel, and there are two metrics, super simple. How many bits, and what's the quality? What's the quality? Like the speech guys, they have some kind of a measure that is called mushra. Again, it's some kind of a quality, how natural it is for human ear. Higher the better, and the bit rate. So if you're thinking about it, you see on the upper left corner, you see that, for example, I can create something that is 10 times more efficient and as almost best quality that is happening right now in, for example, all of these vocoders. So basically, I can create much, much more efficient, that are 10 times more efficient from a bit rate perspective. And for me, looking at these things, it's pretty impressive. I'm going to show you a video. So this is, for example, something that we can do, it's called emotional transfer. So I'm just going to play the video. I can say, for example,
yes, it was a man who asked, a stranger. It was a man who asked, a stranger.
So I can take a voice and transfer the emotional state of that using LLM for speech.
Since then, some mysterious force has been fighting us at every step. Since then, some mysterious force has been fighting us at every step.
The fourth and fifth days passed without any developments. The fourth and fifth days passed without any developments.
And there is going to be a lot, if you need, we can put a Zoom plugin that you're going to sound like you woke up at 5 o'clock in the morning if you don't want to talk with people. So yeah, all of these things are happening right now. And in full transparency, this, one of the things, and you see that AI is moving so fast, I consider that pretty old because it was published 12 months ago. So the quality is much, much better right now. So when it's funny, things that are happening in 2022, it's so old for us right now, with everything that is happening in the speech space. And this is one of the coolest examples that I want to show. Remember that, that I talked with you about music? So look at that video. And just read it. So as you can see, for example, I can literally generate music. It's still, let's be honest, it's happening right now. I think that it's going to take a few more months, sometime, again, not years, but until we can generate a lot of applications. But think about the amount of things that we can do with that. So the last thing that I want to talk about is what we call ethics and safety. So I think that hopefully you can understand that using voice cloning audio fakes, I can impersonate someone's voice. And we can also do this in real time. It doesn't have to be real time. We can just jump on a Zoom call, just put some kind of the latest and the greatest text-to-speech system that is open source, and just impersonate someone's voice. And this is what we call audio fakes or voice cloning. And a lot of the times when we are talking about it, people are saying, okay, yeah, and we understand, but there is going to be some time until it's going to really happen. These things are happening right now. Again, I don't want to give people's idea how to do that and which open source and everything like that, but this is very public. So Microsoft released something that is called Val-E. And again, one of the things that is happening with voice cloning is how much data do I need to use of someone's voice in order to create a perfect cloning. So let me just do a survey. How much data do you think? 30 minutes? How much people think that 30 minutes is going to be enough? Oh, shoot. Okay, 5 seconds. Okay, yeah, okay. Actually, the answer is 3. Okay, so okay, so yeah, so 5 seconds, yes. So basically, Valley, you can clone someone's voice in 5 seconds. It sounds super natural. And Valley X is actually what we call multilingual. So basically, for example, they can take my voice and I can speak fluent Spanish, like in the text-to-speech system. So basically, it doesn't have to be just English. It can be any language. So that's pretty scary. And when Microsoft, of course, if you're thinking about all these open sources, like Microsoft, and for the right reasons, didn't publish the code. But one of the things that is happening in the open source community, and again, that people are taking the paper, collecting the data, and creating replicas of that. So Valley and Valley X and a lot of other things like that are existing as open sources. And again, people are actually calling people right now using these technologies, impersonating, and I'm just going to put my cybersecurity hat right now. And when we are thinking about these things need to be very, very careful and really well consideration. So if you're thinking about it, first of all, when you're thinking about these audio fakes, first of all, we need to understand the risk factors. And risk factors is are we talking about enterprise attacks versus consumer attacks? One of the things that is happening is that enterprises have a lot of money to spend to make sure that people are not good, that their customers or the banks are going to be pretty well protected. But think about consumers. I don't have thousands and thousands of dollars to make sure that I can protect my phone. Or even, for example, one of the things that happened, again, these are just in the silence right now, is that people are pretending, people are pretending to be the CFO. And actually, I think 4 years ago, somebody pretended to be a CFO. They called the CEO, and they stole $35 million, and the CEO using audio fakes. So again, it's not happening on a large scale, but consumer attacks are going to be or social engineering are happening right now. First of all, when you are thinking about how to protect, it's always we need to understand what are the attack vectors. Okay, what type of open sources, what are the online learning technologies, how can we protect? Because it's like a cat and mouse thing. So we need to understand, for example, how our attackers are going to think, which software will be used. In order to detect against that, we need to generate suitable data sets of what we call voice cloning, or how to create these classifiers. And we need to build the proper classifier. So there are two things that are happening right now. First of all, people are building classifiers to generate what is synthetic data and what is real data. And classifiers are working pretty well. And the key thing is sometimes people are injecting another layer, is that they're saying, okay, if this is Yishay, how is Yishay's synthetic voice is going to sound like? So I'm going to try to create some kind of a neural network that is called user-specific to add another layer of protection. So basically, that's all. Again, I hope that that you enjoy my talk, and happy to answer any questions. Oh, you're moderating.
Oh, go ahead. Anybody?
Yeah, so first of all, thanks for a great talk.
Oh, thank you.
This is pretty stunning. What's going on? Within this, I'm just wondering about the user application of this for customer support.
Yes. Are you
Go down in that and also link up some of the previous presentation, like you talked about drag, and using drag to augment responses back to customers sometimes. So has that been used so far? Has it been an experience? And
you're talking about the things that we are doing?
Yeah, things like link to LLM.
Oh, okay. So first of all, again, I just in full transparency, I don't if somebody is interested in what we are doing, happy to answer that in the office hours, again, because just don't want to promote our company over this talk. But just, yes, customer support, sales BDR, it's being live, feedbacks are great, people love it. Yeah, so yeah, happy to answer any other questions. Just ChatGPT, yes, it's working. I think that, again, there are need to adapt the systems. In terms of voice, there is always the question of latency, because if you're thinking about text, we can generate that, we can overcome the inference of the LLM, but when we're talking about speech recognition plus text-to-speech, latency is becoming an issue, and this is some of the challenges that, again, voice bots are going to be a little bit more challenging. Okay? If maybe you can... Oh, okay. Okay, so latency is super important. 250 milliseconds, that's something that, people that this is the industry standard. Yeah, it's real time, it's 250 milliseconds. Translation, it's a little bit more challenging. The reason because, for example, if you're thinking about languages in general, sometimes like words are not in the same order. So sometimes when I'm thinking about real-time translation, I'm thinking about, okay, I need to wait until the user has ended the sentence and then generating the translation. Sometimes I can be a little bit like, a little bit more smarter about it, but this is, that. And yeah, like, these things, like, you saw, like, this is what we're doing in real time. Voice-enabled LLM in terms of like ChatGPT wrapper for an LLM? Yeah. So here's the thing. First of all, one of the things that is happening right now, I think that LLM, at least, they need to be industry specific. As like, for example, people yesterday said in the VC panel, it's like, Swiss Army knife. ChatGPT is a great Swiss Army knife. But if I'm talking about, for example, like, supporting my customers in like, I don't know, in telecommunication, we need to make sure that it's more specific. Another thing that is super important is enterprises are much more concerned and aware about things that, that can escalate. Because if, for example, I'm using a ChatGPT and the answer is not right, that's fine. But if, for example, something is going wrong or something goes sideways from the chatbot, that can be a very, very harmful thing for the enterprise. So these are the challenges. And again, there is a huge difference between a demo and a product. Scaling is another thing. And open sources, there is so variety of open sources. I think that one of the things is just getting the proper data.
Can we take one last question? And then
are you building security gates to prevent people from copying exclusively without any permission anyone else's voice?
Oh, first of all, like you're talking about what the things that we are building? Yeah. So first of all, like, when we started the company, we had a very, very ethical, strict rules of what we are going to do, what we are not going to do. We are going to, for example, controlling the avatars. For example, we are not opening that to an API that you can generate your own avatar. We are generating the voices for customer enterprises. That's fine. And we had a lot of, discussions about it. And again, like, we want to make sure that, people are not going to do that because our aim is to help people understand each other and not, to create malicious things.